All right, so November the 20th, 2020, we're looking at partial fraction. So we're going to start by talking about rational fractions. This says the sum or difference of a number of rational fractions can be combined to form one fraction in the following way. So everybody knows how to add a fraction. Here, the denominator is a binomial. The denominator is a binomial, and this is true if the denominator is a linear factor or not. It is true that when adding or subtracting fractions, if the denominators are different, you must find the LCM. So I'm 100% certain that you guys would be able to add these two fractions and come up with the 5x plus 7 over x plus 1 into x plus 2. I'm sure you would be able to do that, so I'm not worried about that. All right, continuing. Rational fractions can be either proper fractions or improper fractions, and we'll get into that. The full idea of what is proper and what is improper as it relates to rational fractions. It says rational fractions with factors in the denominator can be separated into parts. The process of separating rational fractions into their parts is called partial fractions. All improper fractions must be converted to mixed fractions before separating into parts. For proper fractions, the denominator must be factorized into a product of linear factors and quadratic factors, and the partial fractions will depend on the form of these factors. The denominators can contain A, unrepeated factors, B, repeated unrepeated linear factors, B, repeated linear factors, C, unrepeated quadratic factors, or D, repeated quadratic factors. And we are going to look at all four types over the course of looking at this topic. Now, a rational fraction is one in which the numerator and the denominators are polynomials. A rational fraction is one in which the numerator and denominators are polynomials. All right. Now, a proper fraction is one in which the degree of the numerator is less than the degree of the denominator. And even that, we'll get into the full understanding of that. A proper fraction is one in which the degree of the numerator is less than the degree of the denominator. And an improper fraction is one in which the degree of the numerator is greater than or equal to the degree of the denominator. You will see the full understanding of that. So let's look at our first type of partial fraction. So the first type we're looking at is proper fractions, unrepeat linear factors. This says the denominator of the proper fraction consists of unrepeated linear factors of the form ax plus b. For each factor of the form ax plus b, there is a corresponding fraction of the form a over ax plus b, where a is a constant to be found. For example, p of x, which is some function of x, over ax plus b plus cx plus d plus ex plus f is equal to a over ax plus b over cx plus d plus c over ex plus d. All right, and that might not mean a lot to you, but as we progress, it will become clearer. All right, so here's example one. I'm going to do example one just to show you exactly how it's done. And then I need for you to afterwards look at example two. Example one says, separate 5x plus 7 over x, x plus 1, x multiplied by x plus 2 into partial fractions. All right, the denominators consist of unrepeated linear factors. So the linear factors are x plus 1 and x plus 2. So they're unrepeated. If they're repeated, you would have something like x plus 1 square, but they're unrepeated. So according to what we just read, 5x plus 7 over x plus 1 into x plus 2 may be separated into partial fractions of the form a over x plus 1 plus b over x plus 2. All right. So if you so a partial fraction of this form, when you separate it, it looks something like that. The partial fraction, sorry, the rational fraction to the left consists of unrepeated linear factors. And when you have unrepeated linear factors, this is how it's separated. And our objective is to determine what is A and what is B. All right. Now, here's one approach that we could take to it. First thing I'm going to do is I'm going to get rid of the fractions. And one way to do that is to multiply the entire equation by the denominator over here. Multiply the entire fraction by the denominator to the left, which is x plus 1 multiplied by x plus 2. So let's do that. Now, if I do this, I have what, 5x plus 7 over x plus 1 into x plus 2. And I'm going to multiply by the same thing, x plus 1, x plus 2. I'm just doing it, spelling it out for you to see exactly what happens. This is a over x plus 1 multiplied by x plus 1 into x plus 2 plus b over x plus 2 multiplied by x plus 1 multiplied by x plus 2. So all I did is I multiply the entire equation by the denominator on the left. When I do that, I'm going to end up with 5x plus 7 on the left. This cancels that. This cancels that. And on the right, I'm going to end up with a into x plus 2, because this cancels that, plus b into x plus 1. And our objective is to determine what is the value of a and what is the value of b. All right, here's one approach. I could get rid of a by saying get rid of b by saying that when x is equal to -1, when x is equal to -1, you will notice that if x is -1, -1 plus 1 is 0. So 0 multiplied by b is going to be 0. So this over the right is going to disappear. So we're going to have 5 into -1 plus 7 is equal to a into -1 plus 2. b into x plus 1 is going to disappear when x is equal to -1. So on the left, I'm going to have -5 plus 7 is 2. And on the right, I have what? -1 plus 2 is 1. 1 times a is a. So a is equal to 2. Remember, my objective is to find both a and b. I can also say when x is equal to -2, to get rid of a, when x is -2, on the left, I'm going to have 5 into -2 plus 7 is equal to a, this is -2. So -2 plus 2 is 0. 0 times a is 0, so a disappears. plus b into minus 2 plus 1. Minus 2 plus 1 is minus 1. So on the left, I'm going to have minus 10 plus 7. On the right, I'm going to have minus 1 times b, which is minus b. So minus b would be equal to minus 3. If I divide both sides by minus 1, I'm going to get b is equal to 3. So now that I know what a is and what b is, I can then say that 5x plus 7 over x plus 1 multiplied by x plus 2 is equal to a, which is 2 over x plus 1 plus b, which is 3 over x plus 2. All right. And this is what they mean when someone says partial fraction. The objective of partial fraction is to separate the rational fractions like what we have on the left, into what they call partial fraction. All right, it's sort of like the reverse of adding it. If you add whatever is on the right, you're going to get what is on the left. So this is partial fraction is sort of doing the reverse. Doing the reverse, which is like coming from the sum back to its constituent parts. All right, I just did example 1. I'd like for you to try example 2. Questions and comments?